This is solving polynomials. Let's begin. We want to make sure we understand what it means to solve polynomials and then how can we solve them. So just like with quadratics, solving means we want to find the roots, which are also zeros, solutions, and x-intercepts. So we're looking for where this polynomial will cross on the x-axis. So we can do that by graphing, right? So we can see where they cross. You can also factor, and then you set your factors equal to 0. Remember to find what your x is. The other thing you could do is the quadratic formula. So don't forget that. Hopefully you still remember that from quadratics. Now, another thing to remember is that a polynomial of a certain degree will have that same number of roots. So if we have a polynomial like this is a simple example, but the degree is the highest exponent, so this is a 4th degree polynomial. That means it should have 4 roots. Now they can be real roots or they could be imaginary, but total would be 4 roots. So let's practice solving this polynomial. So just like with the quadratics, I want to get this polynomial in standard form. Okay, I'm going to solve this one by factoring. So I have x to the 4th minus 13x squared plus 36 equals 0. So I moved these two terms over here. That's why this is negative and positive. Now I have a standard form of a polynomial. I'm going to solve it by factoring. So for me that means I'll factor this into x squared minus 9 and x squared minus 4, which we learned in the last video over the last couple of days. I can factor this even more to be x plus 3 times x minus 3. That factors to these two. I can also factor x squared minus 4 to be x plus 2, x minus 2. Okay, so we haven't done anything new. We just put this in standard form, factored it as far as it'll go. This is factoring it completely. Now the solving part is that we set each one equal to 0. So x plus 3 equals 0. X minus 3 equals 0. Each factor gets set equal to 0, and then you solve for x. So one of my x's is negative 3, the other one's positive 3, negative 2, and positive 2. So here are all my roots. I just solved. This is solving this polynomial. Okay, so I also have a quartic function. Remember, that's 4th degree, and I have 4 roots. And we could say at x equals plus or minus 3 and plus or minus 2. So remember, that means that this graph will cross the x-axis at these 4 numbers. So here's another example. I have x cubed minus 64 equals 0. This is a cubic function. It should have 3 roots. I'm going to solve it by factoring. So remember from the last video that there's a certain way to factor these difference of cubes. That's what this is called, difference of cubes. And so this would factor to x minus 4 times x squared plus 4x plus 16. So if you've forgotten how to factor these, remember to go back and look at your notes. So the solving part happens now by setting this equal to 0. And I get that one of my roots is x equals 4. Now this part, I would see if I could factor it some more, right? Just like we did in the last example. I can't factor it anymore. Okay, you could try and it wouldn't work. So I'm going to use the quadratic formula. This is a, b, and c. So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times your a. Okay, so when I simplify this, I end up with the square root of negative 48. Negative 48 is my discriminant. So based on that discriminant chart we learned last year, I should have 2 imaginary roots here. Okay, a negative discriminant means I'm going to get imaginary roots. So continuing to simplify this gives me negative 4 plus or minus 4i square root 3 over 2, which becomes negative 2 plus or minus 2i square root 3. All right, so I have a cubic function. I found one real root. It's because this didn't factor, I used the quadratic formula to find the roots, and they were two complex or two imaginary roots. So I have 3 roots, 1 real, and 2 complex or imaginary. And these 4 and -2 plus or minus 2i root 3. So remember what that means about the graph. It'll cross once at 4, and then these tell me they're not going to cross. So here's one last example, x to the 4th minus 16. It's a quartic function. That means it's a degree of 4, so we should end up with 4 roots. So I'm going to solve it by factoring. This would factor to x squared minus 4 and x squared plus 4. I can factor this some more, so x plus 2 and x minus 2. This I would try, but it doesn't factor. So I'm going to go ahead and set these two factors equal to 0 so I can find what my roots are there. And I end up with 1x at -2 and 1x at +2. So I have 2 real roots here. This doesn't factor, so we can use the quadratic formula. So this is a, there is no b, and there's c. So x equals -b, which would be 0, plus or minus the square root of b squared minus 4 times a times c over 2 times my a. So if I continue to simplify that, I end up with x equals plus or minus the square root of -16 over 2. The square root of -16 is 4i, and then when I divide it by 2, I end up with plus or minus 2i. So I do have the 4 roots that I expected. It's just I have 2 real and 2 imaginary, or 2 complex. Now remember that imaginary roots come in pairs, so you can never just have 1 complex. You must have 2. If you have 1 imaginary root, then you must have 2. Okay, so that's what this tells me. And remember about the graph, that it's going to cross at -2 and +2, and then it's not going to cross because imaginary roots don't cross the x-axis. All right, don't forget your essential questions and summary. Please go back and rewatch the video as needed until you completely understand the solving part of the polynomials. All right, that's it for now. Thanks for watching.